Hello and good day, pre-algebra. Today we are going to be going over math packet number 11, if I can press the right button in the right order there. Due May 4th, it's your second to last math packet of the year, and I highly encourage you to turn this in ahead of time so I can check it over. You can kind of see if you're on the right track with certain things need to be fixed. Overall, it's going to help your grade when they're actually due, because you'll kind of know, have a test run for what's right and what's wrong. So this first question here we talked about in class today, actually. It says in April, 20% of the customers at Auto World bought blue cars. Of those customers, 15% chose gray interiors. What percent of the customers at Auto World did not choose a blue car with a gray interior? Now, at first, it might seem kind of a disadvantage or kind of annoying that we aren't told how many customers there are. Okay, all we are given to work with are percentages, no actual firm values here. We can use that to our advantage, though, because that means since we're only talking about percentages, we can kind of choose how many customers we want to work with at Auto World. Okay, especially since our answer is also a percentage, it really doesn't matter how many customers we start with as long as we can calculate the percents. So we want to choose a number that's easy to work with percentages. And since the word percent literally means out of 100, let's start with 100 customers. Okay? And then it says 20% of those customers bought blue cars. So our first task is to calculate 20% of 100, which in class today we said was 20. See? So easy to work with, right? So 20 customers bought blue cars. Of those customers, and this word those is important because it's not referring to the original 100, it's referring to those 20. So of those 20 customers, 15% chose gray interiors. So our next calculation is 15% of 20. And what that number represents, what that percentage represents, is the percentage of customers who bought blue cars with gray interiors. What our question is what percent of the customers at Auto World did not choose a blue car with a gray interior? So the example that we talked about in class, and this isn't the right answer, so don't use it, but the example was if 60% bought blue cars with gray interiors, what percentage didn't? Well, if 60% did, it means that 40% didn't, right? If 80% of a group do something, that means that 20% of the group didn't, right? So the answer to this is kind of going to be what's left after you find the percentage that did buy blue cars with gray interiors. The rest of the group, what's left, is your answer, those that did not choose it. The next page, Tina left her house at 9 a.m. to ride her bike on a very long road at a speed of 12 miles per hour. At 10:30 a.m., her sister Vanessa left the house on her bicycle and tried to catch up to Tina. Vanessa rode at a speed of 20 miles per hour. At what time will Vanessa catch up to Tina? So in class, we kind of started making a table with this one. We said, here's Tina, here's Vanessa, and at 9 a.m., Tina starts out, but actually at this time they're still both at 0 because at exactly 9 a.m. Tina leaves. She hasn't gone anywhere yet. Okay, but then at 10 a.m., how far has Tina gone? Well, if she's going at a speed of 12 miles per hour, again, we just got done talking about rates, 12 miles per hour, then in that hour from 9 to 10, she went 12 miles. Oh, makes sense. And Vanessa still hasn't left yet. Since our next time given is 10:30, we're going to just jump a half hour here, which is okay. As long as we use the proper rates, we can have any time frame that we want to here. But if Tina goes 12 miles in an hour, how far will she go in half an hour? And in class, we said, well, that's going to be 6. Right? 12 miles per hour is 6 miles and a half an hour. And it's at this point that Vanessa leaves. She's still at 0, but at least she's left. Okay? So then we said, okay, let's go another hour from here. Might as well. Now looking at 11:30. Tina will have gone another 12 miles. Oh, whoops. Whoops. It's easy for me to erase that. Hopefully you can erase that too. She went 6 miles for a total of 18 miles. Okay? So if she goes on another 12 miles now from 10:30 to 11:30, that brings her total up to 30. Vanessa, who has now been riding for an hour at 20 miles per hour, has gone 20 miles. Okay? Vanessa's catching up here, right? When Vanessa left, she was 18 miles behind. Now she's only 10 miles behind. So the question is, at what time will Vanessa catch up to Tina? Which means we're looking for the exact time when these two numbers match. And I say the exact time because I don't want your answer to be about 3 o'clock or a little before noon, okay? It needs to be an exact time. So you might find yourself needing to jump increments of an hour until you get really close. Then maybe go back to a half hour, maybe even more specific, down to 15 minutes even, okay? But using those equivalent rate strategies that we talked about in our last unit, those are the ones you want to use to answer this question. Then we have the 5-card challenge. Using these 5 cards, total the 6th, and that card is a 10. So have at it. Make sure you are getting at least 15 points, and use a calculator to check your answer. It makes the most sense. Your calculator always uses the proper order of operations. So type exactly what you put in, put that exactly into a calculator, and if you get 10, then you know that you're right. Next page, the area of the shaded region. So you have to find the area of the entire figure, which is a square. And if you've got 2 triangles here that are each a length of 6, then we know that a side length of the square is 12. And since it's a square, well, then that means that all sides are equal to 12, right? So that's a way you can find the area of the entire figure. Then, to find the shaded region, remember that the area of a triangle equals 1/2 times the base times the height. Okay, not a very good triangle. None of my sides actually connect. There you go. 1/2 times the base times the height. And there are 4 of them there. All the triangles are the same size. And so you can get the area of the shaded region using those formulas. Next one, our pattern block question, looking for the number of green blocks, blue blocks, and total blocks. In class, we started working with this. We kind of filled out what we knew. We know that the first block, or the first figure, has 1 green block. The next figure has 5 of them. The next one has 9 of them. And the next one has 13 of them. And it didn't take us long to see the pattern that was developing here. And we looked at the blue blocks. I'll use my blue marker for this. Makes sense. The first figure has 8 of them. The second figure has 16 of them. The third figure has 24. And the fourth figure has 32. And it didn't take us long to identify the pattern there either. And then we said, well, by golly gee, if we know how many green and blue blocks there are, then it's pretty easy to find the total blocks. 1 green and 8 blue give us 9 total. And then 21 total. And then 33 total. And then 45. And we also mentioned a pattern that we noticed was developing here. You may not use it because if you can find the green and the blue, you can add them to get the total. But if you wanted to kind of check your answer, check yourself, then you could find that pattern with the total blocks and see if it matches up, which it should. So your job for this one is to complete this table down to the 8th figure. Then we have our surface area question. First of all, you need to draw a net of the figure and label its sides. And then for pre-algebra, given that x is 3, find the surface area and the volume of the figure. So there are 2 answers that I'm looking for here, surface area and volume. I do give you the value for x though, so you can take that, plug it into x minus 1, and that will give you the side length for that side. And then recall that surface area is the area of all the faces, all 6 faces added together. And the volume for a rectangular prism, that formula is base times width times height. Okay. Next one, the Magnificent 7, for which I give you the volume for 7 solids we talked about this year. You need to give me the formula and the values of the sides or the height or the radius or whatever that brings us to the given volume. And you have to do 3 of those 7. 3 of those 7. Next page, we have our math exploration. Bring Fibonacci and Pascal together. We've talked in each packet this year about either Pascal's triangle or the Fibonacci sequence. This relates the two, of course. They're so amazing on their own. There must be something that connects them. Well, this is it. So what are called the shallow diagonals, I've kind of drawn them in for you. And your job is to give the sum of each shallow diagonal. So you follow this first one here. It passes through a 1. The sum is just going to be 1. This one passes through a 1. The sum is 1. This one is 1 and 1, which gives us 2. This one is 2 and 1, which gives us 3. Here we have 1 plus 3 plus 1, which is 5, and so on and so forth. And when you're done, I want you to look at the numbers that you get. This sequence of numbers here going down this rectangle here, what is significant about that sequence of numbers? Okay, what is significant about that sequence? We've got the first 5 here, 1, 1, 2, 3, 5. If you continue this, what is significant about that sequence? Then the next page, mean, median, mode. Instead of me giving you a situation where you find the median, find the mode, find the mean, now you get to give me a number set with certain conditions. Your data set needs to have 7 numbers with a mean of 30, a median of 32, and a mode of 26. So 26 has to be in your number set at least twice, because it's got to show up the most for it to be the mode. Your system, your set also has to have a 32 in it as the median, to where if you order the numbers from least to greatest, it's the one in the middle. Other than those 2, you get to pick the other 5, right? You don't necessarily have to include a 30 in your actual set. That's just the average, okay? So you must have, I should say you get to pick the other 4, because 26 has to be in there at least twice. So you must have at least 2 26s. You've got to have a 32. Those are set numbers, but then the average of them, the other numbers after that, get to be your choice. Okay, so a mean of 30, mean of 32, and a mode of 26. Then the last page, polynomials here. Where in the figure does each of those 8 polynomials appear? Remember, they aren't flipped, they aren't rotated, they aren't nothing like that. You need to identify where they are. Okay, so that's math packet number 11. Like I said, is due May 4th. You can turn it in early for me to check over. I highly recommend it, not only for your bingo game, but also so that you can get a better grade on it, probably. All right, folks, thanks for watching. That's How You Math. Don't forget to like and subscribe, and have a great day.